Fluorinated ethylene propylene, or FAP, is a film that plays an essential role in LCD and DLP 3D printers. An object standing at 150 millimeters or 6.1 inches in height requires at least 3,000 2D layers of individual curing that's released over FAP film. Thus, maintaining releasing properties and mechanical strength are crucial for consistent printing results. FAP, or known to the world as Teflon, is well known for non-stick surfaces and chemical inertness. It will continue its non-sticking properties well beyond 1 million curing layers. However, in reality, after several prints, regular FAP film will crumble, resulting in failed printings and creating resin spills that can ruin expensive 3D printers. FAP is chemically inert but mechanically weaker than the plastic trash bag. You can easily stretch it with your bare hands. 3D Materials introduced a new brand, Super Durable FAP for 3D printers, which is made of high-quality FAP film laminated with optical-grade PET film. 50 micrometers of FAP film is laminated with 50 micrometers of PET film by 25 micrometers of optically transparent silicone adhesives. It gives a total thickness of 125 micrometers. Therefore, one side that is sent to resin is FEP, and the other side that goes to LCD is strong and durable PET film. When replacing the FEP film of resin vat, place Super Durable with its blue protection film facing upwards, and the clear film on the other side should be facing downwards towards the LCD. And don't forget to remove both blue and clear protection films before full assembly. If you forget which side is FEP, an easy test is to make a mark on the film with any marker. If the marker stays in its original shape, you've marked the PET side. If the mark becomes a dotted line, then you've marked FEP side, which should be placed towards resin. How strong is Super Durable FEP compared to conventional FEP film? Let's measure the tensile strength of both films using UTM machines and compare their results. In UTM machines, a dumbbell-like standard sample is cut and removed using a special cutting tool. The thickness of the samples are measured, and then each side is grabbed by a crosshead of UTM and pulled in opposite directions at a constant speed. The load cells that connected with a crosshead measure how much force is needed to pull and stretch the film. Force divided by the area of the cross-section of the film give tensile modulus in megapascals, or MPa. The higher the number, the greater the force is needed to stretch the film. In this test, conventional FAP film shows near 8 MPa before it begins to stretch. However, 3D Materials Super Durable FEP film laminated with PET needed almost 50 MPa before it began to stretch. That's 5 times more than of conventional FEP, 5 times stronger, 5 times more durable. If you're tired of the constant changing of film and reassembling after every 10 to 20 prints, then try using 3D Materials Super Durable FEP. It's competitively priced to meet or beat the retail value of conventional FEP. It will save you time, money, and the tedious task of assembly and disassembly. Please stop by our Amazon's 3D Materials store. Enjoy new approaches in 3D printing and 3D materials.